Lesson 8, Joule's law. Now, Joule's law. Okay, so we've looked at Ohm's law, and we'll come back to Ohm's law, and we've looked at resistivity, and Joule's law now is the next big one regarding the current electricity. Okay, and it basically deals with what happens if you apply a current to a resistor. Okay, we know there's a heat loss. Okay, we want to find the relationship between the energy change per second and the current. Okay, so if we look at this scenario here, okay, so I just have a little bit of resistance wire, power supply here. Okay, we're not too worried about the power supply. I'm turning on the power supply, low current at the moment, low voltage, turn up the voltage. And there you go. Okay, we get our heating effect pretty quickly. Pretty impressive, right? Okay, so basically what we have is we have a resistance, nichrome resistor. Okay, we have a large current going through it. Okay, and we're getting this heating effect. Right, okay, so the question is, what's going on? How do we deal with it? Try to avoid burning the place down here now. Okay, right. Now, okay, so basically Joule's law states that power is proportional to I squared. Okay, now remember power, we keep going back to power. Power from our mechanics is energy per second. Okay, so power, work over time. Okay, so basically remember it's the energy per second. This is something that's really important now to get your head around again. Okay, so if we talk about a 12 watt bulb, okay, we're talking about 12 joules of energy per second. Remember, we all said that. So power is energy per second. Anytime we see power, we say energy per second. It's better. If we forget about the word power and just say energy per second, we'll all be delighted, but we don't, so we have to say energy per second. Energy per second, power. Right, okay, so we're here. Now, if it's proportional to, we know it's equal to a constant, times I, times I squared, and the constant is R. Now, this constant is R for Joule's law, and it's also the same. It's also constant is R for Ohm's law. Remember, V over I is a constant, and the constant is R. So it's quite interesting. Joule's law and Ohm's law have the same constant. Joule's law and Ohm's law are very much almost the same thing. Okay, we treat them separately, but remember, they're best friends. Okay, right. Okay, so P is equal to RI squared. That's our first formula. Now that's the formula, and this, we call this the heat loss formula as such. Okay, when you're, it's very important. Okay, when we were dealing with this one a minute ago, okay, let's have to break, so it won't work for us now. Okay, when we're dealing with that one, okay, we can find out the energy per second there by finding the resistance of that length of wire and multiplying by the current squared, and we would have found the energy per second be converted into heat energy. So this is the heat loss formula. We didn't need anything else. Now, instead of R and I, we could also, let's say we wanted V and R. Okay, so we need to remove I. So if we want to remove I, to get another form of this, we know from Ohm's law that I is V over R. So we take P is RI squared, and we say P is R, instead of I we're putting in V over R squared. Be careful here, remove the brackets, and we end up with this. So R V squared over R squared, and we end up with a value of P is V squared over R. Okay, sorry, P is V squared over R. Right, that's not in the tables. You need to know that. Okay, you need to know that one. It's handy, right? And then also, if we're not given, if we want, let's say V and I, so we want to get rid of the R, start with P is equal to RI squared. This time we want to get rid of the R, so we say R is V over I from Ohm's law. So P is equal to V over I times I squared. So it's V I squared over I, and that simplifies down to V I. And there are three forms. Now that's the form that we use for energy transmission, and we'll see in a second why. So there are three forms. Okay, that's what we're interested in. They're the three forms. Right, we want to look at more detail about those now, so I'm just going to rub them out and just put them down on top. Okay, so I don't have enough space. Okay. Okay, so we've just said effectively, and you'll find this in your notes as well, that P is proportional to I squared, P is equal to RI squared, P is equal to VI, and P is equal to V squared over R. Now you really need to know the three of those. Okay, that's in your tables. This is in your tables, so that kind of follows from there, and this isn't. Know the three of them. Okay, back in the good old days, you have to know them all. Know those three. Alright, okay. Now, back to the idea that power is energy per second. So remember, if you see this, this means that the energy per second is VI, the energy second is per second is RI squared, the energy per second is V squared of R. I want you to be able to, at any stage, without having to write it down now and learn it off, if you know the three of these, you know three more formula, you know the energy formula. Because in this case, what if it was 2 seconds? Well, it would be V by I. This is for energy of 1 second multiplied by 2. If it was 10 seconds multiplied by 10, if it was 20 seconds multiplied by 20. You know what we'd be doing if we're in the classroom. Bang, 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 bang. Okay, if it's T seconds, multiply by T. Okay, so E is equal to VIT. Over here, exactly the same. If it's 4 seconds, it'll be 4RI squared. If it was 27 seconds, 27RI squared. And if it's T seconds, RI squared T. And this formula, that's going to be hugely important in the experiment, which we're going to look at in a minute. Okay, and finally, in this case, you would have energy is V squared over RT. You don't need to learn these three. Know those three, and remember, to change from power to energy, you just multiply by the number of seconds, multiply by T. Okay, this will be, as I said, very important to us as we go along. Okay, so that's Joule's law. Okay, so it relates to the heating effect. We have three forms of it. Okay, using 2 out of 3 of V, I and R in each case. This we call the heat loss one, energy losses, the heat losses, okay, and this is then the energy transmission. Why can't I use this or this for energy transmission? Well, let's just imagine, okay, this is in a SCARA, just probably spelled wrong, in a SCARA dam producing energy. You have all the leads, the wires going to your house. Here you are. This is your house. And there you are, self-isolating. Okay, right? If you were to use either this formula or this formula, you would have to know the resistance of everything in here, all of this, and everything in here. It's not an option. If you're transmitting energy, the only formula that we can use is P is VI. So the energy per second being transmitted is the voltage multiplied by the current. Okay, that is the bottom line. Okay, we will return to that. And when we're tidying up later on, when we're talking about high voltage power lines and so on, but not today. Okay, right now. So that's that. Okay, we're now going to look at our next step is going to look at the Joule's law experiment.